Hello everybody, welcome back. My name is Olduk and I'm officially back right here, okay? Today we're gonna discuss some physics right here. Mass due to simulate magnetic effect into the DOM itself, into the web. Whether you're a friend developer, a beginner, a rookie, or even a master, you're gonna learn something from this video. Even if you're a mass enthusiast or not, you're gonna learn a little bit right here, okay? So we're gonna discuss a linear interpolation and a lerp. Okay, what's the linear interpolation in mathematics? First of all, let's discuss the linear interpolation. A linear interpolation, if you searched about a linear interpolation in Google, you're gonna find a Wikipedia, for example, or any kind of dictionary for terms or definitions. You're gonna find it's a method of curve fitting to construct new data points within the range of unknown data points. So if you're having a value of A, which is 1, 3, and a B, which is 3, 5, you want to get point C in this range. So let's visualize this. So we're having a diagram like this, and axis line and a y-axis line. This point is 0, 0, and we're having a point right here, and we're having a point right here. Let's call this 3. Let's call this 2, for example. Let's call this 2. Let's call this 4, for example. And we're gonna draw the lines. We're gonna draw the lines like this, okay? And we want to get a point in the range between this point and this point along the way to reach this point. So we want to get a point right here. Want to get a point right here, for example. So that's going to help us draw a line between 2 points on the diagram right here. Actually, I think that's just the same way of drawing SVGs, the passes in SVGs, all these kind of Illustrator graphs. I don't know. I'm just thinking like this. And that actually, push us to the lerp function. What's the lerp function in math? We searched about the definition of lerp function. It's just a function that eases animations. So it's used to find a point some fraction of the way along the line between 2 endpoints. It has a bunch of formulas. We're gonna use this formula right here, which is A multiplied by 1 minus T, which is the factor. A is the coordinate, plus B multiplied by the factor itself. B is the target value. So let's visualize. So we're having a point right here. Let's call this A, okay? Let's call this A, which is equal to 0. And we're having a point along the way right there at the right. Let's call this B, which is equal to 20. So we want to reach from 0 to 20, okay? And instead of we're having a value x equals 0, we're gonna change this to be 20. That's gonna be an instant animation in memory. So we're actually changing values like this. It's just gonna be an instant animation. We don't want this. We want to change, instead of doing x equal 20, we want to change, or we want to actually, move by a fraction. So instead of 20, of moving this the whole value, moving to the target value. Okay, we're gonna move by 5 fractions, for example. So we're having 0, 5, 10, 15, till we reach 20. So we're moving by a fraction right here. That's the lerp function in a short term. Okay, so what we gonna do? So first of all, we're having a DOM right here. We're having a DOM, an element inside of a DOM, and that's it. So what are we gonna do with this animation? So first of all, we're actually gonna draw a visible, okay, an invisible lines like this, like these. Okay, let's make this at the center of the button itself. So we wanna draw like invisible lines like these in the DOM. Okay, whereas the center of the diagram is the center of the button itself, whether the button is at the center of the screen or at some other places on the screen. So that's the first step. So how to get the center of the button itself, and how to draw these invisible diagram. First of all, we're gonna use the bounding line rect on the button itself. So we want to get the left and the width and height and top. These values, gonna use these values to reach the center of the button itself on the screen. So we're gonna actually sum the left and half of the width to reach the center of the button on the X perspective, and the height half of the height at the top to reach the center of the button from the Y perspective. So now we're at the X0 and Y0 point, okay, on the of the button itself. So yeah, we're now at the center. We left plus width divided by 2, top plus height divided by 2. Now we got the X and Y value. Now we are at the center right now. We're good. That's a good step for doing the animation. So what we need, so that's the current value, which is this is the current value, and we need a target value. This target value, we're gonna actually use the mouse to get this target value. So we're gonna move the button towards the cursor itself, you know, the position of the cursor. We're not gonna move it 100%, we're gonna move it by 20% or even a fraction of the distance, okay, to make the animation more elegant. So we actually tracking the mouse position X and Y with the page X and page Y. We're calculating the distance between the cursor point right here and this, like the center of the point itself. If the distance is this, then the zone we actually gonna define, do the animation, which is moving, which is all about moving the button towards, you know, the cursor. I told you 20% of the distance we're gonna calculate right here. And if it's not inside the zone itself, we're gonna get back, you know, we're gonna reset the button values to be X0 and Y0, and that's it. So we're gonna calculate the distance. If the mouse position in the red zone, do the action. If not, redo the action. I'll undo the action. Whatever. Let's get back to the code right here. So what do we have right here? It's like a simple HTML structure right here. It's like the simple template, a script module to import the TypeScript module code right here, and there's a simple div and a button is inside of it with a class duck and a type button, and there's a CSS file import right here, and that's our CSS. So there's a div with a grab and please can select default styles, and the thing that I'm caring about is the active class down there, which is the class that's gonna identify the button status as active or not. And yeah, we're good to go. So let me actually remove these. Okay, we're good. So now we're having a magnetic, we're having our files like here, the lib, we're having a magnetic and magnetic types. Okay, so let's create our types. So let's actually export at type magnetic type, which is gonna be a generic over T, and that's gonna be an object of elements. Okay, this element is gonna have a type, and we're gonna have trigger error. And what are we gonna have? We're gonna have a factor. We're gonna have a mouse position. We're gonna have a lerping data, and we're good to go. So first of all, we're gonna have an options inside of our object. So these are the values the user actually gonna have control over. So the user gonna change these. So what are these values? We're gonna call them opts. So it's gonna be a generic over T. It's just gonna receive these values right here. Okay, and now let's extend these. Extend the opts. I'm gonna pass the generic T. We're good to go. We are cool. Okay. So now let's create the elements type and the trigger. Let's create the types themselves. So export type elements. It's gonna be a generic over T, and we're gonna check if the T extends at elements, which is we're gonna infer the type of the E itself, of the E right here. We're gonna check if the E actually extends. If the E extends, if you want to check if it's iterable or not, you can actually use iterable, but I'm gonna be more specific, and I'm gonna use node list of HTML element. And if it's yes, we actually put a question mark right here. And if it's yes, return the E. If it's not, return never. It's not, return never. Okay, I'm gonna copy this a bunch of times right here. So FE. So that's gonna be the trigger area. And FE. It's gonna be the trigger area, okay? And we're gonna check if it's equal to the number itself. Okay, we're gonna copy this. We're gonna get back right here, FE, the FS, and we're gonna say the factor type, FE, the factor, not for each factor. What's factor? It's called factor. Fact, FT, factor. Factor. Okay, we're good to go. So now we're having the type for element, trigger area, and the factor. So we're gonna pass the elements with the T, and the trigger area with the T, and the factor with the T. Now we're good. Now we're having everything down right here. So what else we need? We need the mouse position type. So export type mouse position, which is gonna be an object of X equals number and Y of number. Okay, and export type lerping data, which is going to equal to a record of a string and a current of number and a target of number. So we're going to use the mouse position and the lerping data, and we're good to go. Now the type system is done right here. Okay, now the type system is done. So let's create the class itself right here. So export class magnetic. Okay, magnetic, and it's gonna be a generic over T that implements a magnetic type, the generic over T. And let's import the elements, and let's use the trigger area. Let's use the factor, mouse position, and the lerping data. And we're gonna have a constructor right here. This constructor gonna have an obs, which is a title. We're gonna pass the generic. The T, we're gonna have this dot elements get equal to ops dot elements, and this dot not lerping data. It's just gonna be the trigger area gonna equal to ops dot lerping, this dot trigger area, and this dot factor gonna equal to ops dot factor. Okay, we're gonna have this dot mouse position gonna equal to, we're gonna initialize this value, gonna x gonna equal to 0 and y gonna equal to 0, and we're good. This dot lerping data gonna equal to an x, which is having a current of 0 and target of 0. Okay, we're gonna reach our x, fx, and our y, and the constructor is done right here at this point, so we're good to go. Now the class is initialized. So first of all, we're gonna track the mouse. So private get mouse position, just gonna be a function of void that returns window dot add event listener mouse move, and a e, which is a mouse event. Okay, it's gonna return this dot mouse position equal to an x of e dot page x, and a y, which is a e dot page y. And yeah, we're good to go. And we're gonna close the method itself. Now the mouse position is triggered, and let's trigger the mouse position, the get mouse position. Okay, and we're gonna have another render function right here. Let's create it. Private render, which is gonna be a void avoid method right here. First of all, we're gonna console. We're gonna get the mouse position values right here. So the x and y gonna equal to this dot mouse position, and we're gonna console dot log x and y, and we're gonna request an animation frame to get the updated value. So window dot request animation frame, and we're gonna have a callback function to this dot render. Okay, we're good to go. So now let's initialize the mouse, the class itself. So const, let's get the elements. So elements can equal to document dot query selector all. I'm gonna have dot doc, and all of this as a node list of HTML element, and we're gonna have trigger area. It's gonna be 200, and we're gonna have factor, which is a 0.8, and we're gonna have an ops, which is gonna be elements trigger area factor. We're gonna have we're gonna initialize the class self counts foo, which is gonna equal to new magnetic. This is gonna be a generic over ops, which is gonna be a generic of type of the ops. We're gonna close this. We're gonna initialize this by the elements, which is gonna be the elements, and the trigger area gonna be the trigger area. And what else? We're gonna have the factor, gonna be the factor. We're gonna close this. It's working pretty good right here. So it's initialized. So if I went to the website right here and I moved my mouse, I get the current value of my x and y value right here. So the class is working pretty good right here. So what else we need to do? We need to get the distance. So let's get the distance. So private get distance. Yeah, just gonna ask for a x1, which is a number, and a y1, which is a number too, and an x2, which is a number, and a y2, which is a number, and it's gonna return a number. And what else? It's just gonna return a math.highPot. I'm gonna explain what it is right now. x1 minus x2 and minus x2 and y1 minus y2. Okay, and I'll close this. Okay, so what is exactly math.highPot? Let me get back to this right here. So math.highPot is like it's actually getting the square root of x1 minus x2 all of a square plus y1 minus y2 all of a square. That's it. It's pretty simple. So it's back to the code. So let's get the distance. Okay. So now TypeScript right here doesn't know. TypeScript right here doesn't know that the else, this dot elements, it just doesn't know it's a node list of HTML elements. So I'm gonna tell it, hey TypeScript, it's a node list of HTML element. Okay, I'm gonna let you know this is a node list of. So L dot for each L, I'm gonna do some actions right here. So first of all, I want to get the bounding client rect. So these values I'm gonna need is the width and the top, the height, and the left from L dot get bounding client rect. And when I calculate the distance gonna equal to this dot distance get distance when I pass the x and the y and the top and now the left plus half of the width divided by 2 and the y2, which is gonna be the top plus the height divided by 2. And we're gonna have a target holder. A target holder is gonna hold the initial values. Okay, x gonna be 0 and y gonna be 0. So what's the the purpose of the target holder? So if I'm having, or let me get back right here. So as I told you, if the cursor is outside the zone, I want to get back. I want to transform the button position to be at the point 0, 0. And if it's not, if it's in the zone, I'm going to change the values to be other values. So I'm going to use this to control, the flow. So I'm going to have got right here, if the distance is less than this dot trigger area, I'm going to do something right here. L dot class list FOD and dot class list dot add active. Want to copy this, and else we're gonna remove the class. So we're good, we're fire. Let's get back to the website, close this. If I'm inside this zone, look, the class is active. If I'm outside this zone, the class is not active. It's working, so it's fire right here. So let's get let's set the target holder values dot x gonna equal to x minus the left plus width divided by 2 all, and with the fraction I told you, the fraction I need 20% of the distance itself. So x gonna be y global intensive, and that's gonna be a height, and that's gonna be a top, and we're good to go. So we're gonna set this dot lerping data dot x dot current. I want to set the current value of the lerping data. We're gonna use this lerp data to loop over them. So this dot it's just gonna equal to the target holder dot x, the same. Just gonna be the y. We're good to go. So we're gonna lerp over the data, the lerping data. So that should be an item, and if deleting this dot lerping data, we're gonna delete these, and we're gonna store the value const val gonna equal to this dot lerping data item, and we're gonna use this dot lerping data dot del lerping data item dot current gonna equal to this dot lerp. I haven't actually created the lerp function yet, so private lerp gonna equal to a function that take current, which is a number, and a target, which is a number, and a factor, which is a number, and returns a number, and it's actually gonna return a current multiplied by 1 minus the factor, okay, plus the target multiplied by factor, and we're good to go. Okay, we're good to go. So I'm going to use the lerp, where I'm going to pass the val.current and the val.target and the factor, this dot factor, and yeah, we are good to go. Now let's transform and let's move the button itself. So l.transform.style.transform gonna equal to translate, and first of all, this dot lerping data, the axis first of all, the x dot current, okay, in pixel, and this dot lerping data dot y dot current in px2. Pretty good, pretty fancy. Okay, now it's moving. Look at this, it's moving, as you see right here. As you see right here. So if I increase R4, if I increase the value, just gonna move way faster. If I make this R8, for example, just gonna move, just like to make the animation more appearing, like right here. So the animation, you can actually control the amount of the button gonna travel by this fraction right here. And yeah. And I think the animation is done right here. It's working. And if you're having a bunch of elements, okay, I want to actually copy these a bunch of times. Just like giving you, oh yeah, that's working right here, and that's working right here separately. That's working right here. It's working right here. This is working right here. Oh my god, this is an error right here. So I should actually add the scroll. You could actually, yeah, and yeah, this is working right here. And all of these buttons are working. So there's an error you could fix, okay, which is added in the scroll Y while added in the distance itself. If you want, but I don't need it right now, so the animation is working right here. To fix this issue right here, you should add the scroll Y to the distance itself. You want to add the X and Y value. That's it. I hope you guys enjoyed this video, and peace, nerds.